Hi class, we're going to get started here on case number 4. If you have any questions or concerns, you can always email me or give me a call. I want to go over here is the first question that we have. And so in here is we do have some math equations that we're going to go over. So for each of the 4 work team sizes, calculate the expected number of trucks in the queue to be unloaded. So in question 1, what we want to do for all 3 of these questions is create this little chart right here. I'm going to go ahead and just put borders around that in there so that we can say, hey, we're going to copy that data and put it into the next 3 questions. All right, so for question 1, what we're trying to do here is to find out the expected number of trucks in the queue to be unloaded. So in doing that is our first equation over here, the average number in the queue. So what we're going to do is we're going to take 4, because that is our queue number, and we're going to take it to the power of 2, and that would be our 16. And then we take 5 times 5 minus 4, right, and come out with a 3.2, or 16 over 5, which would give us 3.2. You can see right here, that's how my equation is written out in Excel. You might want to do it on pen and paper at first so that you get a hang of it. There's nothing wrong with that. And then coming back to Excel and putting it into Excel. In doing that, what I'm going to do here is I'm going to then drag that down because I have that number in I have that equation already done, pre-filled in with these lines here. So by dragging it down, I'm going to limit the errors, and I'll get the same title here. Now the next one here that we have here is our question 2. Our question 2 is asking, and what we do is we have the same chart here as well. And what it is asking is the expected time in the queue. So how long is something going to be in the queue? And then for that equation here, if we look here and we see that we have our our average time, right, over our unloaded, which is 5. Same bottom part equation here. 5 times 5 minus 4, which is 1, and we come up with 0.8 hours. And then what we do here is that we go ahead and we drag these down here. Now the next question, question 3, is for each of the 4 work team sizes, what's the probability that a truck cannot be unloaded immediately? All right, so here is that we have 5, 8, 10, and 11 as the unloading ability. The trucks in the queue is 4, 4, 4, 4 again. We're going to do a little bit customization of this one right here, our average time in the system. So what I do here is I take 1, and then I take my 5 divided by 5, which will give me that 0.20 of that 1, and then we'll have a probability of 8%. It gets a little trickier here because we're using an odd number in there, and so it comes a little bit different in there. You can change that around to show that the odd numbers are in there, but we do have a probability of 0.36 or 36% chance that someone would have to wait upon arrival. Now, with that covers each one of these. You'll write that. You'll provide a chart in your paper as well. I provided the chart in the handout template as well. Okay, you guys have been doing a great job with your papers. Here's your name, title page, abstract, next page, keywords. Some of you are still forgetting to do the keywords for your abstract in there. Make sure that you do include it. Title of the paper. I had here the introduction paragraph just to tell you about that. Some of you have been adding that to your header. I didn't mark down. It's actually incorrect. You don't need that header. You just need the title of the paper and then go straight into your introduction paragraph. If you're leaving it, it's not that big of a deal, but just so you know that it is there. For here is you have question 1. Should that be your header? I just put this in there for you to look at those and have those. Okay. So question 4, that we had was our labor negotiations are coming up, and Wayne thinks that he can get the union to give away on the work rule that prohibits warehouse workers on unloading dock from being given other assignments when they're not unloading trucks. How much would Wayne save in his own loading dock costs if he could reassign warehouse workers to other tasks when they are not unloading trucks, assuming that he has picked up a good team of workers and each worker works 8 hours a day? So, in order to do this, we will have some idle time, and I showed you how to calculate that down. It shows, for example, 24 minutes per hour is spent unloading trucks, and the rest of the time is idle. And that means that he can get 36 minutes of work. So, a lot better timing in there. And you can see that we had the $14 an hour that they were getting. So Wayne could save up to $8.40 per worker per hour, assuming that he could assign them other tasks where they were pay rates were in there the same. So make sure that you include that in your question 4, and don't forget a Christian perspective and then a conclusion. Now remember, some of you are including the ISBN number in the reference page. You don't need to add that, so go ahead and don't, but just make sure that you're including the reference pages. Of course, any questions or concerns you have, please let me know.